So, ladies and gentlemen, I'd like to introduce you to Lukas, who is going to pronounce his own second name for me very shortly.
Vaclavik.
There you go. I'm glad I got him to do it. Lukas has spent more than 15 years in the food and dietary supplement testing. He currently works as a global technical manager for contaminant and residue analysis at Eurofins Food Integrity and Innovation. Eurofins, by the way, do have a stand here. Just point the direction of your stand over there.
Yep.
Lukas is responsible for coordinating and performing complex method development projects, identifying and solving technical problems, and developing new analytical strategies for new ventures in EFII. Prior to joining Eurofins, he worked for the Center of Food Safety and Applied Nutrition in the US Food and Drug Administration in the US. Lukas has authored and co-authored over 40 scientific publications, journals, articles, and book chapters, mainly focused on chromatographic and mass spectrum analysis, chemical residues, contaminants, and adulterants. Is that right?
It is, yeah.
Sounds a bit odd, adulterants to me, but there you go. He received his Ph.D. in food chemistry and analysis from the University of Chemistry and Technology in Prague in the Czech Republic. Ladies and gentlemen, if you just give a warm welcome, please, to Lukas from Eurofins. Thank you.
Thanks for the kind introduction, Robert. So this presentation will be slightly different. It may get a bit technical, so I'll try to explain as much as possible. So we'll be talking about chemical testing. I'll provide an overview of tests, chemical tests that are basically relevant to hemp and hemp-based products. I'll also want to talk about some challenges that are faced by commercial or third-party testing laboratories in the area of hemp testing. And I also want to touch topic of method validation process and also accreditation of laboratories. And at the end, I want to provide some conclusions. So I think it's fair to say that we are entering age of cannabinoid. In the past, hemp plant has been used mainly in agricultural and industrial applications, but since then we learned a lot about this plant, and recently this plant has been used to produce cannabinoids and other biologically active compounds, which are being added to different items that range from oils to cosmetics and also edibles, including confectionery or bakery products. So this is definitely an emerging area, and it's very interesting for testing laboratories. There's a great business for testing laboratories there. The reason behind the growth is the potential benefit or health benefit of cannabinoids and other components of hemp plant. So based on comprehensive scientific studies, it has been demonstrated that the health benefits of hemp, or in general cannabis plants, is linked to multiple components, which are cannabinoids, terpenes, and phenolic compounds. Rather than individual compounds, it seems that all these bioactive components create the potential or the positive health effect, and this is called the entourage effect. So the main question here is why to test your product. Obviously, you should test your product to make sure that it's legal, that it's compliant with applicable regulation on the market that it will be marketed on. You also should ensure that it's safe in terms of chemical and microbiological safety. You also want to accurately label the product. You want to make sure that all its components are stable. So another thing to consider is the stability of your product. Again, testing can help you with that. And you can also understand the composition, and based on the results of testing, you can optimize the composition of your product, which can be particularly interesting for growers, for example. If you are breeding your plants, you can optimize it for highest cannabinoid content, or you can make it rich in terpenes, etc. So there's another area which testing can help. The other question is what to test for. So obviously you want to test cannabinoids, you want to test potency of the product. You can also test terpene profile. Both cannabinoids and terpenes are natural components which are in the plant and in your final product. On top of that, there's a number of different contaminants. These include residual solvents that may be present in your product because of incomplete removal during a manufacturing process. There may be pesticide residues that are, remain on your product. Natural contaminants such as mycotoxins and also heavy metals. Last but not least, there's a need for micro testing. You want to make sure that your product is free of harmful pathogens such as Salmonella, E. coli, or coliform bacteria. So this is an overview of the challenges. There's a number of technical challenges that are faced by testing laboratories in this arena. First of all, hemp samples can be really, really complex and difficult to analyze with even modern analytical testing. This applies especially to concentrated samples like full spectrum isolates, etc. In addition, since this is a developing market, there are new products being developed, and this again poses a challenge to testing because not all testing methods may work in all different types of matrices. Again, we also need to constantly update the number of analyses we test for just to keep pace with applying regulation, and that's a major drawback. There's a lack of standardized methods that could be directly implemented in the labs. And then there are challenges that are linked to the market itself. So obviously there's a push to deliver testing at low price, and this can be accomplished by optimization of the method using cost-efficient method and also high throughput method that allow you to deliver the results in time. Finally, there are challenges with logistics. Shipping samples between countries can become really challenging, especially if your testing sites are in different countries or even different continents. So, when it comes to cannabinoid testings, there's more than 100 cannabinoids known, these have been identified in hemp plant. The major ones are CBD, which is the major cannabinoid in hemp plant, and THC, which is major cannabinoid in marijuana. However, there are additional cannabinoids such as CBN, cannabidiol, CBG, cannabigerol, or CBC, cannabichromine. There are two forms of cannabinoids, neutral forms such as THC and acidic form, THCA. Most of the routine methods are limited to major cannabinoids, and the scope of the method, that means the number of analyses that are being determined in a single method, range from 3 and maybe focused only at THC and THCA, or can be a bit broader and include also additional compounds of up to 16 compounds. The workflow of the method is shown in this slide. You need to get a representative sample which needs to be homogenized and then extracted. So you extract the cannabinoids into a solution. You may clean the solution up so it doesn't interfere with the determination, and then you analyze using instrumental methods. So there are basically two approaches to analysis of cannabinoids. You can use either liquid chromatography or gas chromatography. In liquid chromatography, the sample extract is introduced into a stream of liquid, which is called mobile phase, and this is the sample is passed through a column, which is filled with a sorbent. And the analytes, or the cannabinoids, have different affinity to the sorbent. And based on their physicochemical properties, they separate. And they are detected in the detector, and you obtain a record in which each so-called analytical peak is one of your compounds. In GC, on the other hand, you work in gaseous phase, so the sample extract is introduced into injector and is heated up, and the separation is carried out using a long capillary column in a stream of gas. And again, in this particular case, the cannabinoids are separated based on their volatility and detected. So there are certain advantages and disadvantages to these approaches. Most of the approaches used in routine are currently in the routine are based on liquid chromatography, because it allows you to determine the complete profile of your cannabinoids. That means you can determine both neutral and acidic cannabinoids. In gas chromatography, because you are working at high temperatures, your acidic compounds will be transferred into neutral compounds. So, for example, if your sample contains THC and THCA, it will be converted to THCA, and you will see only only THC that is neutral peak. Again, with GC, you may need also to do some extra preparation steps like derivatization. And both liquid chromatography and gas chromatography are operated with different detectors. For example, the most frequently used detector for liquid chromatography is the UV detector, while gas chromatography is usually used with flame ionization detector. And both LC and GC can be coupled with mass spectrometry detection, which is way more sensitive and selective compared to those two detectors mentioned before. And depending on what kind of detector you use, you will be able to determine different lowest concentration of cannabinoids in your sample. So I already mentioned gap in standard methodology, and this gap was recognized by AOAC International, which is basically a non-profit organization focusing on setting standards in testing. And AOAC International put together a panel of experts, and these guys put together so-called standard method performance requirements for testing of cannabinoids in dried plants and concentrates. And these method performance requirements basically put together requirements on performance of methods to be used for testing. They also provided a list of compounds to be included in those methods. So we, as a Eurofins company, we took part. We developed a method and we submitted it to AOAC, and it actually got an AOAC official status. So our method became official method to be used for analysis of cannabinoids. And since that time, we also expanded the number of cannabinoids to be used. Currently, we are able to analyze for 16 cannabinoids, and we also expanded the matrix scope of our method. So on top of dried plants and concentrates, we are also able to test in cosmetics and edibles such as gummies and vape liquids. But sometimes, LC, UV may not be enough. Use of mass spectrometry, which is another detection technique, allows you to analyze at way lower detection limits of quantification. So it allows you to determine accurately way lower concentrations. Equipment to perform this type of analysis is quite expensive. Typical mass spectrometer costs several hundred of thousands of pounds, but it gives you unique opportunity to analyze at low levels in really complex matrices such as chocolate, etc. So why would we do it? Well, the reason is because currently applicable regulation requires you that your product should contain less than 1 milligram of THC in that particular container. And containers may be different, right? It may be 10 mils, it can be half a gram, it can be half a kilogram, it can be a kilogram. So if you're marketing a container of 1 kilogram, your limit of quantification should be less than 1 milligram per kilogram. And LCMS technique allows you to do that. So let's move on. Another group of interest is terpenes. These are volatile compounds that are responsible for flavor and aromatic profile. And there's a number of different terpenes, some of which are specific to hemp, and these are actually listed in these slides. However, there are additional terpenes. And terpenes are particularly important in products that lack their own aroma or flavor. So they are often being added to the final product. And on top of the flavor and aroma, it also these compounds may also have biological activity. There's not much known about it, but there are some indications there may be considerable biological activity of these compounds, and they definitely contribute to the entourage effect of hemp plant. So how to test for these compounds? As I said, these are pretty volatile compounds, so you can easily use gas chromatography. The technique we use is called headspace gas chromatography mass spectrometry. In this type of analysis, you put your sample into a glass vial and you incubate that sample at elevated temperatures. So you force all the volatile compounds into the headspace above the sample. And then you basically take an aliquot of that sample and you introduce it to the GC where the separation takes place, and you get a nice chromatogram that provides you with the terpene profile of that particular sample. In this case, it's a terpene profile of a hemp oil sample. The method we use actually allows to analyze more than 40 terpenes. So, in addition to hemp-specific terpenes, we can also analyze other terpenes or terpenes from other botanical sources. And nice thing about this is that it's really minimum sample preparation, because you just place the sample into a vial and the rest of testing is done automatically. Let's move on. Another group of contaminants or compounds of interest are residual solvents, and these are byproducts of extraction processes. So when it comes to cannabis extraction, there are different approaches used. You can use alcohol extraction at different temperatures. People interested in getting product or extract high in terpenes will use butane and propane extraction at low temperatures, and supercritical carbon dioxide extraction is becoming a standard approach in hemp extraction industry. So as already mentioned, some of these approaches are safer or more hazardous when it comes to contamination, because you shouldn't look only for the extraction solvent itself. Your extraction solvent should be of high purity, but if that's not the case, it can be contaminated with various minor components which are toxic and can make it to the final product. So a list here actually is based on California law that is implemented in the US. But there are also additional compounds we can test for. And again, considering residual solvents are volatile compounds, we use headspace GCMS for analysis of those. Another group of compounds, pesticides residues. So pesticides are being used to protect the plants from pests, diseases, etc. The contamination may take place in several ways, one of which is application of excessive amount of pesticides and its insufficient degradation. So basically pesticide stays on your plant, and many of these compounds are actually quite stable, so they can make it into your final product. On top of that, hemp plant is known to be able to absorb compounds and contaminants from soil. So in case you are cultivating on contaminated soil, you can get those compounds into your plant and into your final product. And one thing to consider is that during the manufacture process, those harmful compounds get concentrated. So it will be way higher concentration in your final product compared to the plant itself. And there are more than 1,600 compounds which represent, pesticides, or their metabolites, or degradation products and impurities that have been used or are being used. So, actually, this type of analysis is quite challenging, and to be able to cover as many compounds as possible, you should always use modern approach, which is multi-residue approach, used or realized by GCMS and LCMS techniques that allow to cover hundreds of pesticides in a single analytical run. So again, what we are doing, we have an analytical method that allows you to determine more than 500 pesticides in a single run. And our method is specifically optimized to deal with complex matrices. So we can deal with nasty stuff like, full spectrum isolates, etc. And on top of that, we are using both LC and GC. And for some compounds, we can use both techniques. So there's an overlap in terms of analytes, which give us advantage when it comes to identification of positive hits in samples. Moving on to heavy metals. Heavy metals can get into your product by contamination from soil, and your soil can get contaminated if you are using poor quality fertilizers, or it might have been contaminated previously. Additionally, you can contaminate your product also during the manufacturing process. So the elements of concern are arsenic, cadmium, lead and mercury. The approach that is used in this testing is called inductively coupled plasma mass spectrometry. So basically you take the sample, you decompose the whole organic content in that sample via the process called mineralization by using high temperatures and inorganic acids. You dissolve the residues in suitable solvent, and then you analyze using ICP-MS. So again, with ICP-MS, we are able to cover all these elements. Again, and I highlighted the 4 that are specifically relevant to hemp. Mycotoxins. Mycotoxins are natural compounds. These are secondary metabolites of certain strains or species of fungi. The concern with mycotoxins is that they are highly toxic. And, with regard to hemp plant, the most relevant mycotoxin that can be found are aflatoxins, and these are actually the most toxic mycotoxins of all. The other problem is that they are very resistant to thermal processes, so they will make it.
I'm signing up to let you know you've got a couple of minutes left for questions, etc.
Okay.
Finish at 25 past.
25, okay. All right. So basically, they can survive treatment with high temperatures, again, and make it to the final product. We are using LCMS, and to be able to go to really low concentration, we are using something called immunoaffinity cleanup. So we are using antibodies specific to mycotoxins to remove them from the sample, concentrate them, and then analyze by LCMS. Okay. Another topic, method validation. So it is really important to be confident in the method we are using. That's from both testing laboratory and client perspective. So to ensure the method is valid and suitable for its intended use, we perform method validation. Here's an overview of some of the validation parameters that we determine. The validation of the method is performed experimentally. So one of these parameters is selectivity. And selectivity demonstrates that you are able to determine your analyte in the presence of other components in your sample. You also need to determine your limit of quantification. So that's basically the lowest amount of analyte that can be accurately determined with your method. Accuracy just says how close you are to the real content of your analyte in the sample. Precision is how close will be the repeated determinations performed on a single sample. And robustness is another validation parameter that kind of indicates how resistant the procedure is if you make small changes to it and how it will affect your results. So if we consider that testing is shooting at a target and the true value is in the middle of the target, if your method is inaccurate and imprecise, you will get a situation on the very left hand of the slide. On the other hand, accurate and precise methods we are trying to use will provide results like this on the right hand. Yeah. Okay.
Some of you probably will think this is a dry subject. I'd have to disagree with you, because I think that where we are now within the industry, it is absolutely critical that we have validated, accurate testing that is also useful. I work within the industry myself, so we have our own products and we have them tested. We currently use Eurofins, so there's a quick endorsement. However, it's taken us a long while to come round to find a testing body and an organisation that can test appropriately. So, and what I mean by that is, you may get test certificates which get you down to, 0.03. There's a popular limit of test that I've seen on some of those certificates. In my humble opinion, that's pretty useless. When we're talking about having a test which needs to prove that a product is safe and there's less than 1 milligram of THC or a controlled substance in the final product, you need to make sure that your testing goes down to the appropriate levels. That's why we currently use Eurofins. Does anybody have any questions? Lukas? No budding scientists in the room. There you go, sir. I'll come over.
Hi, I'm just wondering, what's the cost of a complete cannabinoid, terpene, heavy metal, mycotoxin? What's an average cost of that test?
Stop by at the booth. We have a special price for this event as well. So what I can say, the test for cannabinoids is around 60 quid. Pesticides more expensive. Slightly more expensive, and but we can provide all the information at the booth that way.
That's great. Well, we are running out of time. If you would just show your appreciation, please, for Lukas and his scientific knowledge. Thank you very much.